How to test whether X is a member of a universal set. I have a list L, and X and L evaluates to true if X is a member of L. What can I use instead of L in order X and SMTH will evaluate to true independently on the value of X? So, I need something, what contains all objects, including itself, because X can also be this SMTH.
You can inherit from the built-in list class and redefine the underscore contains underscore method that is called when you do tests like item and list.
Theorem: there is no universal set. Proof: let X be a set such that X equals \empty X, where X is every possible element in the domain. The question arises, is X \n X? Most sets are not defined that way, so let us define a new set Y. Y equals a \n X, a \node in A, i.e. Y is the set of all sets not belonging to themselves. Now, does Y \n Y? Well, we have defined Y as all sets not belonging to themselves, so Y cannot exist in Y, which contradicts our assumption. So now assume Y is not in Y. Now it definitely contains Y, as Y is not in itself, but the definition of Y is such that if we define Y to be in Y, we contradict our own definition. Thus, there is no set of all sets. This is known as Russell's paradox. So, why programmatically try to create an object that violates a result proved and tested by set theorists far more intelligent than I am? If that was my interview, this would be my answer, and if they insisted it was possible, I'd suggest explaining what the problem domain is, since conceptually Russell has fundamentally proved it is impossible. If you want a user-friendly problem usually posed for people studying introductory set theory, try the Barber paradox. Edit: Python lets you implement an object that contains itself. See this. However, this is not a strict set theoretic object, since the contents actually contains a reference to the parent object. If you require that objects be distinct as per the proof above, this cannot happen.